Good morning, students. Welcome to video lecture on electromagnetic waves and transmission lines. Subject code U18EC403. Topic vector algebra. Uh, Let us discuss some units and dimensions which are useful in this course. Always consider distance in terms of meters, electric charge in coulomb, energy in joules, energy density in joules per meter cube, angle in radians, voltage in volts, current in amperes, electric field intensity in volt per meter, magnetic field intensity ampere per meter, electric flux density coulomb per meter square, magnetic flux density Weber per meter square, electric flux in terms of coulomb, magnetic flux in terms of Weber. Scalar and vectors. A scalar quantity is represented by its magnitude. A vector quantity has both magnitude and direction. You can refer to the sample scalar and vector quantities. A scalar point function, for example, a scalar point function can be represented by a pi is equal to some x, y, z. A vector A is equal to ax plus ay plus az az. Here, capital Ax, Ay, and Az are the components of vectors along the axis x, y, and z respectively, where Ax cap, Ay cap, and Az cap are the unit vectors along xyz axis respectively. Vector representation. Uh, a vector A can be represented as ax, ay, az. Similarly, B is equal to bx, by plus bz, az. The magnitude is the magnitude of vector A is root of ax square, ay square, and az square. Here, ax, ay, and az are the magnitudes of the vector along xyz axis respectively, and in the same way for vector B, mod B is equal root of bx square plus by square plus bz square. uh, just now we discussed ax, ay, and az are the unit vectors along axis x, y, and z respectively. A point in Cartesian coordinate system is represented by p of x, y, z. Here, x is the distance along x-axis, y is the distance along y-axis, z is the distance along z-axis. Unit vector. A vector whose magnitude is unity is called unit vector. In general, a vector is represented by a bar, and its unit vector is represented by a cap. Here, the unit vector a cap is equal to vector a bar divided by modulus of a bar. Uh, Refer to a sample problem to calculate the magnitude and unit vector. Dot product. The dot product of any two vectors a bar and b bar. Here, a bar represented like this and b bar represented like this. and the angle between them is theta of AB. Uh, the dot product of two vectors A bar and B bar is A dot B. It is equal to modulus of A modulus of B, and cos of the angle between them. The dot product of two vectors is a scalar quantity. Another type of representation in terms of components of vectors, and here uh, E dot B is equal to mod A mod B cos theta. Here, if the cos value is equal to 0, means the dot product is 0. That implies the two vectors A and B are perpendicular to each other. Cross product. Uh, Here, consider vector A bar, vector B bar on a plane. Theta AB is the angle between them. Then the cross product of these two vectors is represented by A cross B. It is equal to mod A mod B sine of the angle between them, and the cross product is a vector quantity, so its direction is represented by a n cap. Here the direction of a n cap is perpendicular to the plane containing the vectors a and b. And one more notation for a cross b in terms of determinant, refer to this equation, and its expansion is shown like this. Angle between two vectors. The angle between two vectors can be calculated based on dot product mod A mod B cos theta AB. Here cos theta is equal to A dot B divided by mod A mod B sine of the angle, that is calculated based on A cross B mod A mod B sine theta AB. In terms of vector, it is A n cap, and suppose we want to calculate the angle is in terms of magnitude, so you can calculate the magnitude on both sides, LHS and RHS, that is sine theta AB is equal to modulus of A cross B divided by modulus of A and modulus of B. The scalar triple product. The scalar triple product of vectors A bar, B bar, and C bar can be defined as A dot B cross C is equal to B dot C cross A is equal to C dot A cross B. Here, for this representation, you can consider A, B, C in clockwise direction. A dot B cross C or B dot C cross A or C dot A cross B. You can follow the clockwise notation to represent the scalar triple product, and its determinant is given by this equation. By calculating the determinant using this matrix, you can calculate the value of A dot B cross C, that is the scalar triple product. Vector triple product. Vector triple product is represented by A cross B cross C, and its expansion is based on back cab rule for easy identification, that is BAC CAB. Just follow the notation to remember the equation. Refer to Sample problem 1 and its solution. Sample problem 2 and its solution. Sample problem 3, angle between two vectors. Sample problem 4, angle between two vectors based on cross product. One practice problem. Thank you. We will meet with the next lecture.